So we're going to determine whether functions are inverse functions, and it's actually very simple if our functions are listed as ordered pairs, and all we have to do is look at the two functions and see if the ordered pairs are reversed, and the x and the y are reversed. But if they're actual equations, then it might not be too obvious whether they are inverses of each other. So we're going to use composition, believe it or not, of functions to determine whether two functions are inverses of each other. We talked a couple of videos ago about how one function can undo another function, and if that's the case, then they are one-to-one invertible. And so basically we're looking to see what happens when I compose this. If I take the f function, if I take the g function and place it in the f function, would I indeed get the identity function, meaning an x? If I do it the other direction, would I get an x? So if these end up giving me x's, just plain x, then we know that the two functions are inverses of each other. So I'm going to start off using different colors. I'm going to say, okay, I'm going to put the g function in the f function. Here we go. Take the f function and write it down, okay, but without the x. And in place of the x, I'm going to put the g function. Alright, so let's go ahead and simplify and see what we get. Okay, that's me composing the f after g. Alright, so here we go. I'm going to take 3 and I'm going to temporarily bring this over to the side, and we're going to say 1 over 1 divided by 1 over 3 minus x. That's 1 over 1 times 3 minus x over 1. When I multiply those together, I'm going to get 3 minus x. Okay, so that's going to now become that. Okay, this right here is this. This minus is this. And of course, this right here became this. Okay, let's take a look. We're going to have 3 minus 3 plus x, which is x. So far so good. We got an x. Okay, now it has to happen with both directions, so let's go ahead and now take g after f. Okay, in other words, of x, we're going to take the f function and put it in the g function. Let's take the g function take the g function and write it, but instead of x, we'll leave an open place. Now we're going to take the f function and place it in there. Okay, let's simplify. Now this time, I don't have a whole number minus a fraction, I just have a complex fraction. But let's go ahead and remove the parentheses by distributing the negative. So I get this, 3 minus 3 plus 1 over x. Well, 3 minus 3 is nothing, so I have 1 over x, and that equals 1 divided by 1 over x, which is 1 times x, which is x. So, guess what? Both of them gave me x, therefore we know that those two functions are inverses of each other. Let's take a look at one more example. If I can move it up a bit here. Okay, let's take and find f after g of x. So we're going to take the f function and place the g function in it. Okay, now they're wanting me to multiply this 3 times. And then, alright, that's what that means. Now don't panic. if I multiply these three things, is there any way that I'm going to get basically a 27 plus x? Because that's what I'd have to have if in the end it's going to end up being an x. There's no way. This is not going to be equal to that. And so these are not inverse functions, but sometimes you have to just go ahead and compose them and write out some of the steps before you can tell whether it's not going to work. It's not going to end up being an x. So if one of them doesn't end up being an x, then we don't need to even worry about the second try. Okie doke. So I hope this was helpful for you, and we'll see you next time.